In this video, we're going to go over the review for 4.1 and 4.2. So the first question says, classify the triangle by its angles. Okay, and I give you the words that you're going to use. So it's either going to be acute, right, obtuse, or equiangular. So look at this first one, and the fact that this angle is greater than 90 degrees tells me that the triangle can be classified as obtuse. Okay, the next one, this box indicates that that's a 90-degree angle, and a 90-degree angle classifies the triangle as a right triangle. Okay, this next one, you have to do a little work. So for one, we know that we have two angles that are given that are 75 degrees. Okay, so that makes up 75 plus 75 gives me 150. That means there must be 30 degrees left in the rest of the triangle, because every single triangle has to have exactly 180 degrees. No more, no less. So given the fact that now I know all three angles, I can classify this triangle as acute, because, let me write that better, because every single angle is less than 90. Therefore, to have a triangle be classified as acute, you have to have three acute angles, and we have that. Okay, let's go on to the next problems. Okay, here the problem says classify the triangle by its sides. So by its sides, we're going to use one of these words. Equilateral means all the sides are the same. Isosceles means at least two sides are equal. And scalene means that no sides are equal. Okay, you should go back and look at your notes if this vocab is not coming back up to mind quickly. Okay, so looking at this first triangle, since I have two angles the same, and I know this is the problem I had previously, so I remember that this is 30 degrees up top, that makes this isosceles. Okay, looking at the next triangle depicted in question number 5, I see that this side has hashtags of 3, this has hashtags of 2, and this has hashtags of 1. That means that you have 3 different lengths, and that makes this scalene. Okay, the last one has every single side equal. So if every single side is equal, the best answer probably is equilateral. But remember, by definition, isosceles has at least two sides equal, and therefore you really could call this one isosceles as well. Okay, let's move on to the next problem. Okay, here we're going to find the value of x. Now, I'm not asking you to find the angle, I'm asking you to find the value of x, and I also say to show your work. So, looking at number 7, I see that this is a right angle, so I know that's 90 degrees. Therefore, I know that 2x plus x has to give me another 90 degrees, so that I have 180 degrees in my triangle. Combine like terms, x will be 30 degrees. So now, what I would suggest that you do, plug in this 30, 2 times 30 would be 60, just to verify that you do indeed have a triangle that sums to 180, and you do. Okay, moving on to number 8. So number 8, I have an angle here of 55 degrees. So what I know is that the 3 angles have to sum to 180. So 55 plus 3x plus 2x has to sum to 180. So 180 minus 55 is going to give me 125. So subtract 55 here, subtract 55 here. Combine like terms on the left. Isolate your x by dividing by 5. 125 divided by 5 is going to be 25. Here again, I only asked you to find an x. But what you can do is plug in the x now. That's going to make this 50, and that's going to make this 75. And I can verify that I'm correct, because if I add 50 plus 75 plus 55, I do indeed get 180, so I know that I must be correct. Okay, question 9 is a different type of problem. This is based on the theorem of exterior angles. So these two angles down at the bottom are called remote interior. Okay, so these two angles are the remote interior. This angle right here is the exterior. What I know is that the exterior equals the sum of the remote interior. So 50 plus 70 is what you want to calculate. So 50 plus 70 will give us 120 degrees. So therefore x equals 120 degrees. Okay? So the other thing you should be aware of is if this is 120, this is going to be 60 because these two angles are on the same straight line. And if you add 60, 50, and 70, you find that you have 180 inside, and therefore everything checks. But just to go back, the sum of the remote interior equals the exterior, and our exterior was 120. Okay, that brings us to the next problem. Okay, here I want to find NED. So this angle NED is right here. That is an exterior angle, just like we had on the last problem. These two, far away and inside, are the remote interior angles. So what I know is that the sum of the remote interior equals the exterior. So now you have a two-step algebra problem. Okay, so combine your like terms over here, 5x plus 40, because negative 10 and a 50 is a positive 40, equals 9x minus 8. Okay, now you're really at the two-step problem. I would subtract 5x from both sides. Rewrite your problem. This is gone when I subtract it. 40 equals 9x minus 5x is 4x minus 8. Add 8 to both sides. 48, that's gone, equals 4 times x. Divide by 4, divide by 4, x equals 12. We're not done yet though, because this says find the measure of NED. So NED, we'll do it down here, equals 9x minus 8, and 9 times 12 minus 8 is what we want. So 9 times 12 is 108, minus 8 gives me 100 degrees. That is the angle that we're looking for. Okay, so we can check our work by plugging in for x in the one remote interior angle. So 5 times 12 minus 10 gives me 50. So this is 50, this is 50, this is going to be 80 because these are on the same line, and I need to make sure that my triangle sums to 180 which it did. Okay, so the key thing you want to remember here is that the exterior angle, so the exterior angle equals the sum of the remote interior. Okay, that was a theorem we learned in 4.1. You can go back and look at the notes if you want to have additional practice on this. There's more problems there. Okay, let's go on to question 11. So 11 and 12 want you to do some drawing. So this says, draw a scalene triangle and label the sides with the correct hash marks. Scalene means that there are no equal sides. So give yourself some kind of triangle and label it so that you are indicating to me that the sides are different lengths. That would be a scalene triangle. Okay, draw an isosceles triangle and label the sides with the correct hash marks. So for isosceles, it means that at least two sides are equal. So you can do that. Or, since it's at least two sides, if you had three sides equal, it's technically also an isosceles triangle. So either of those would be valid. Okay, let's go on to question 13. Okay, so what did I do here? Okay, I'm going to fill in what's erased. So let me just look at my sheet and fix this triangle for you so you can see it better. Okay, so I'm okay here. So let's just make the rest of this triangle. And on your worksheet, it said that the lower left corner was 63 degrees and the right corner was 78 degrees. Okay, everything else is fine. Okay, so what do you know? You should know that x plus 48 plus 63 plus 78 equals 180 because there are always, forever and ever, 180 degrees in a triangle. So with your calculator or by hand, you should add 48 plus 63 plus 78. The reason why I'm doing that is because I have added my like terms. Now, do not worry that you have a number greater than 180. Subtract 189 from both sides, and you get that x equals negative 9. So it says to find x and then find the missing angle. Okay, so negative 9 plus a 48 should give you, negative 9 plus 48 gives me 39 degrees. So now let's check our work. I should find that 39 plus 63 plus 78 equals 180. So 39 plus 63 plus 78, and it does indeed equal 180, so I know I'm good. So the missing angle was 39 degrees. That's part of the answer you needed, and x is negative 9. And that would satisfy the requirements for number 13 because it said find x and then find the missing angle. So if you only find x, you will only get half of the credit. Okay, the missing angle was 39 degrees. So make sure you read your question carefully and you answer all of it. Let's go on to 14. Okay, so 14, we did a lot of practice with this. It says, write a congruency statement for the following triangle relationship. So, I say I have two triangles. Are they congruent? Well, let's look. I have a double. We're checking the angles first. A double, a single hash mark, and then a half moon like that. So yes, all three angles are equal. So that's good. I know my angles are equal. Now let's see about your sides. Single, single, double, double, triple, triple. So that works as well. So all my sides are equal and my corresponding angles are equal. My corresponding sides and my corresponding angles are equal. Therefore, these are congruent. Now, remember you're going to write the little triangle. And then I'm going to call the first one RTS. Now you've got to be careful the second time. So how did I do that? I went down the 3 over the 1. So I have to do the same thing here. Go down the 3, and I have FD, and down the 1, E. Put your little triangle symbol, and that's a good congruency statement. Now, let's just check our work. Is it true that RT equals FD? Yes, that's true. And how about TS and DE? That's true. And then RS and FE. That's true. Okay, so now I'm in the position to be able to write my my angles, my pairs, because I'm going to ask you to do this on the quiz. So let's pair up all my angles using your congruency statement. Angle R is congruent to the first one, angle F. The second angle is congruent to the second letter over here. The third is congruent to the third. So what I did was I said first goes with first, second goes with second, third goes with third. That's my angle statement. Now notice I didn't ask you to do this for this question, but I'm telling you I'm going to ask you to do it for the quiz because our other practices have all involved us doing that. Okay, next thing we're going to do, let's figure out the sides. The sides that are paired. So what I'm going to do, let me change my color. And what I'm going to tell you is, let me erase one thing here. Okay, let me show you how we're going to pair these up. Take your first pair, match it with your second pair. So sides RT is congruent to side FD. Put your line segment piece above it, because that's going to tell me that there are line segments, and that's what I want you to say. Okay, then go for the next set of pairs. TS is congruent to DE. Go ahead and put your line segments on both of them. Okay, so then you're going to go first and last, R and S. R and S is congruent, first and last, F and E. Okay, so look at my figure. Is it true that RT and FD have the same symbols? Yes. Look again. Is it true that TS and DE have the same symbols? And is it true that RS and FE have the same symbols? And I can say yes, it is. So that completes that. Okay, so remember, on your quiz, I'm going to ask you to give me the pairs of angles and the pairs of sides with all the correct notation. So be able to do that. Be able also to write a congruency statement given a triangle with these kind of notations. Okay, that brings us to 15. Okay, so 15 is a type of problem that we've gone over before. So let's do this carefully. I'm going to make this a little bit bigger. Not that big. There we go. Okay, so let me change my color. Okay, so the first question says LX, so line segment LX is congruent to what other line segment? So I'm going to look right here. Do you see how LX is paired up with IW? So that's what my answer is. Using my contingency statement, I'm going to answer that. Okay, so LX and IW. Okay, next one. Angle I is congruent to what angle? Well, angle I is the second angle here. So it's congruent to the second angle there, angle L. Okay, angle A, which is the first angle, is congruent to angle G, which is the first angle, for the second triangle. Okay, now we have to have different answers. Do you see, so I'm going to change my color just to emphasize this. Do you see this little m? That's saying the measure of angle I equals. So it doesn't want to know which one is it congruent to. It wants to know what its measurement is. And I look, and I don't have a measurement for I. But then I remember, wait a second, I can go back and use my congruency statement. And angle I is the middle. Angle L is the middle. I don't have an answer for angle L either. So I have to start thinking, how am I going to figure this out? I have angle X. Angle X has to be the same measure as angle W. So go ahead and make this a 92. Okay, I see I have angle G. Angle G is the same measure as angle A. So I can make angle A now a 55. So I can now solve the angles of the triangle by saying 180 minus 92 minus 55, and I'm getting 33 for the remaining angle. So I had to do a lot of work here. So what I just did was say 180 minus 92 minus 55, and that gave me 33. Okay, that was the missing angle. That's the angle they want. So now I know the measure of angle A is 33 degrees. Okay, look at the next question. Because there's no line segment symbol on here, this is saying to you, what is the length of line segment IW? Well, I don't have that. So I look and I say, well, IW has to match LX, and I know LX is 4, so this has to be 4, and it's centimeters, so that means that this length is 4 centimeters. Okay, so here they changed the order of the letters, so LAX. So let's look at your original statement. All they did was invert the A and the L. So do the same thing to the other little triangle. Invert the I and the G, and IGW should be the order we want. So let's just check. L is 33 degrees based on my figure. I is 33 degrees. That's good. A is 55. G is 55. X is 92. W is 92. Bingo, we got it. Okay, so that's how you handle this problem. Okay, you have more practice in your homework and in the 4.2 review we did if you want to see this type of problem again. Okay, so this number 16 is a stretch. So let's talk about this. I see that TZ is 3, and I see VW is 3. I see that VY is 1 plus 1, so 1 plus 1, and I see TX is also 1 plus 1. Now here's where it gets tricky. I see that WY is 2 plus a mystery. I also see that XZ is 2 plus a mystery. That means they have to be the same length if you're adding the same thing to two different triangles. So let's look at this. This is my first triangle here, and then these triangles overlap. So let me get another color. Maybe we'll do a pink. Okay, so then this is the other triangle. Okay, right here. So those are your two triangles. This little piece is an overlap, so it's the same to each triangle, so therefore that's going to help me make these triangles congruent. So now we need a statement. So let me change to a darker color. Okay, so let's call the top triangle VWY. Okay, that's my first triangle. Now, so I went down the 3 and then across the 2 plus the mystery. I've got to do the same thing here. Go down the 3, so call that TZ, and then come across this way, all the way to x. Put your little triangle. That's your congruency statement. Okay, so this problem is a stretch problem, which means it's more complicated than what I would ask you on a quiz, but it's good for you to think about these things. Okay, look at the next one. This is not a triangle. This is a quadrilateral. So I'm not going to need to have a little shape in front, but I need to make sure that they're congruent. So I see I have 1 and 1, 2 and 2, 3 and 3, 4 and 4. Okay, so I have matching sides. Do I have matching angles? 1 and 1, 2 and 2, 1, 2, 3, and 1, 2, 3, and 4 and 4. So yes, I have matching sides and matching angles. So why don't I figure out how I want to name this? If I'm going to name the first one D, E, F, C, let's see how I did that. Okay, so first off, let me erase these marks because they're just going to be in the way. And let's see what path I just followed to name this. So I went down the 2, then I went down the 3, and then down the 4. So 2, 3, 4. So I have to go down the 2, down the 3, down the 4 to name the other shape. So I, J, K, H, done. Okay, so check your angles. That's the quickest way to know you have this correct. Does D match I? Yes, it does. Does E match J? Yes, it does. Does F match K? Yes, it does. And does C match H? Yes, it does. So they all line up, so I know my congruency statement is correct. Okay, let's go on to the next problem. Okay, so let's see what we have here. I see that they want me to solve for x and for y. I see that this angle, that's a single, is 56. So that means this angle, that's a single, must be 56 as well. So if I know that that's 56, and I know, the other thing I know is this. I know that this has to be a right angle over here because these two angles are on the same straight line, so therefore they're supplementary. So I have a 90. So based on that, I know that this top angle right here has to sum with the 56 to be another 90. So take 90 minus 56, and you're going to get 34 degrees here. Okay, so I have both of those expressions now have turned into equations because I can equal them to the proper angle. Okay, so let's go back to how I knew that was 34 degrees. I know that this is 90 because those two angles, this box and next door, they have to sum to 90. So I've already used up 90 degrees in my triangle. The next two angles have to sum to 90 so that I have 180 degrees in total. I knew one of them was 56. I just used subtractions from 90 to get the 34. So I know now that 34 plus 56 plus 90 equals 180. I know I'm good. I have not yet solved for x and y. So this part of the problem is what I'm expecting you should all be able to do. This next part, which we did in class, is a little bit of a stretch. So I'm not going to ask you something like this, but this is a concept called simultaneous equations, and you did this last year in algebra, and you will need to know this for next year in Algebra 2. Okay, so there are a couple of ways that you can solve simultaneous equations. You can solve them by substitution or by elimination. Elimination means you're going to eliminate one of the variables. I'm going to use elimination. I'm going to multiply this top expression by a -2. I'm going to write the result down below. This is going to be negative 10x negative 2y equals negative 68. Take these two equations, add them together. You get negative 6x, those cancel, thus elimination, and then this is going to be negative 12. Okay, so are you comfortable, hopefully, with how I got the negative 12? Divide both sides by the negative 6, and you're going to get that x equals positive 2. So x is positive 2. Once we have our x, we can plug in, so into the top equation if I want. I can plug it in any place, really. Okay, so I can solve now. 10 plus y equals 34. Subtract 10 from both sides, and I get y equals 24. I have now solved for x and y using simultaneous equations. So as I said, this is also a stretch question. I'm not going to ask you to solve using simultaneous equations, but I want to just refresh that in your mind because you will need to have this skill again next year. And it's nice to be able to tie in some of your algebra skills to geometry whenever possible. Okay, so that concludes this review. So I would go over this carefully. Our quizzes next class, you'll be able to do very well if you review this material and kind of think about what we've done before. We also know that you have additional review material in the notes and in the other homeworks. So feel free to go over any questions that you may need extra review on by going over the homework and the past notes.